We live in a base 10 world, probably because we have 10 fingers. So if I write a number in base 10, which is what you're used to seeing, let me write a number. Let's say the number 5087. You know, of course, that this 7 is really in the ones place, and I could write a 1 here. This 8 is really in the tens place, so let me write a 10. This 0 is really in the hundreds place, and this 5 is really in the thousands place. And notice that every time you go up in place value, you multiply by 10. And I start at the right-hand side, of course, and you're used to seeing this. This is really a 7. This is really an 80 because it's an 8 times 10. This is, of course, a 0, 0 times 100, and this is really a 5,000. Another way of looking at it, of course, is by seeing that each one is really 10 raised to some value. This is 10 to the 0 place. Any number to the 0, of course, is 1. So that's the ones place. This is really 10 to the 1, or 10. 10 to the 1 is the tens place. This is really 10 to the second, or 10 squared. 10 times 10 is 100, so this is the hundreds place. And of course, this would be 10 cubed. 10 times 10 times 10 is 1,000, so this is the thousands place. Of course, if I had another digit, I would multiply by 10 again. Every time I go up in place value, I am multiplying by 10. Well, computers work in a binary system, probably because circuits can either be on or off. So computers only know about 2 digits. They only know the digits 1 and 0, 1 representing on, 0 representing off. So if I were to write a number in binary, it's got to contain just zeros and ones. Let me just write a number. It's a good number right there. That is my binary number. If I want to figure out what that number is in base 10, I really just have to think about the place value. This place value is 2 to the 0, also known as ones place. This place value is 2 to the first. Notice again, I'm going right to left. That's the 2's place. This is 2 squared, also known as the 4's place, and you get the idea. This is 2 cubed, which of course is the 8's place. This is 2 to the 4th, which is the 16's place, and of course the next one is going to be 32's place, and if I kept going, it would be the 64's place. 2 to the 5th, of course, is 32. So if I want to figure out what this number is in base 10, I just have to add up all of the digits where there are ones. In other words, let me just go from left to right here. This is really a 32. It's a 1 in the 32's place. So we really just have to add up 32 plus 8, that's 40, plus 2, that's 42, plus 1 is 43. So this is really a 43 in base 10. And this is what your program really just has to do. Your program has to allow the user to enter a binary number. Now, I would suggest you treat this binary number like a string of characters. Then your program needs to read through, and I would read through from right to left. You're looking at the last character first, and you're figuring out the place value. Well, I would have a variable maybe called place value, and that variable called place value should start at 1, probably. And then every time you look at the previous, at the character before, I'm going right to left. So every time you look at the next character, but when I say next, I'm going from the last one to the first one, you have to double the place value. So your program's going to say, okay, there's a 1 here, and my place value is 1, so that's a 1. I'm going to add a 1. The place value is 2, so I'm going to add a 2. Place value is 4, but there's a 0, so I don't care. Place value is an 8, and there's a 1, so I'm going to add an 8. 0, I don't care. Place value is 32, I'm going to add a 32. So your program is going to go from right to left. You're going to need a variable to figure out the place value, which is going to double every time, and then you have to add up all of the places where there is a 1. This is a very short program. I'm talking like 5 lines of code, but I want you to work out the details. This is enough of a hint. You're going to need a couple of variables. You're going to work right to left, and it shouldn't be that tricky. Test it for a couple of binary numbers to make sure that it works, and get to work.